Welcome students. In this video, we will be discussing about reversing a linked list. One of the very important technique that we want to learn, reversing a linked list. Okay, so fine. So directly we will get into the session. So I have taken a linked list already with 5 elements, 12, 24, 13, 45, 32. And to reverse a linked list, there are two ways to do it. There are two different techniques that we can do. And after finishing these two techniques, we will find which one is going to be the efficient way of reversing a linked list in the analysis part. But now, first one is reversing element. Reversing element means first node will this 200 node having address 200 will remain the first node. But what we will do, we will interchange the data alone. The 32 which is on the last node will be taken to the first node, and the data 12 on the first node will be taken to the last node. Then 24 on the second node will be taken to last second node 45, and 45 will be taken here to this 345 node. This will remain same. So elements will be reversed, elements will be interchanged, nodes will remain the same, but elements will be interchanged. That is one way of reversing elements. Second one is reversing link. So no data will be transferred. Only thing is that the last node will become the first node, and last node of next will have the address of this node, and this 45 having no node having data 45, the next will be having not the address of 32 but the address of 13. 13 will be having the address of 24. 24 will be having the address of 12, and 12 will be having null, which means 12 becomes last node, and last node becomes the first node. All the links are actually reversed. So only the linking, the storage of address is only reversed. So either reversing elements or otherwise reversing links. First we will look into reversing elements. Actually speaking, reversing link is the preferable method. But I'm going to show you also reversing elements, and I'm going to do analysis, and I'm going to show you why reversing link is a better approach. Okay, fine. Now, first of all, taking reversing element. For reversing elements, what we are going to do? Right. For that, we will be taking an array. Okay, remember, we'll be taking an array of same size. How many elements? 5 elements that we have. So take an array, take an array of size 5. Okay, so it is going to be block 1, then it is block 2, then it is block 3, then it is block 4 and 5. Okay, it's block 4 and just 5 alone. I think I've taken a large long array, but take only 1, 2, 3, 4, 5. Okay, so let us take the indices 0, index 1, index 2, index 3 and index 4. Now what I want to do is, we want to traverse over this linked list, take each and every element, and we have to copy it to the array. So let this name of this array be ARR, and we will take initially the index I pointing to variable I pointing to 0th index. Okay, fine. Now first we will be taking a pointer temp, because we will never use first pointer to traverse, because that is having the address of the first node, which should not be changed at any cost. So here we will take one more pointer which is referring to the first node. Name of it, let it be temp pointer. So it is storing the address of the first node, so which means it is pointing to the first node. Now temp of data 12 is taken and it is stored in the first ith index, which is 0th index. So 12 is stored. 12 is stored here. After 12 is stored here, temp will be moved to next node. So temp equal to temp of next will happen. So now what we will do, we will take 24 and address of 24 345, and we will store it here. So after copying data, we will be moving the temp pointer. So now the temp pointer is referring to second node. Now also you have to move I also. So temp have to also move to next node. I also have to be moved to the next it have to be moved to the next index. So I will be moving from 0 to 1th index. Now again, take the present temp of data, store in now the present ith index. So 24 is stored in 1th index. So 24 will be stored here. After storing 24, temp have to be moved to next node, I have to be moved to next index. So first we will move I to the next index, and then we will take the address of the next node 100 and we will store it here in the temp. So now temp is storing 100, which means that it is not pointing to second node hereafter, it will be pointing to the third node. So now the link is between temp and the third node. Fine. Now the present temp of data 13 should be copied to ith index, second index. So 13 should be now in the second index. So 13 should be here. Yes. Now move ith index to next one, move I variable to next index. Okay. And also take the address of the next node, which is 210, and store it here in the temp. So now 210 is stored here. So now temp, instead of pointing to this node having address 100, it will start pointing to the node having address, it will start pointing to the node having address 210. Now take this temp of data 45 and copy it here to the third index, ith index. So 45 will be copied here. After copying, what I need to do, temp also should be moved to next node and I also should be moved. So I we will move. Okay, let me move I. Okay, let me move I to the next index. And now let us take the address of the next node 250 and store it here in temp, which will make temp point to the next node having address 250. So hereafter it will not refer to the node having address 210. It will start referring to the node having address 250. So it will start referring to the last node. Take temp of data 32, copy it to the ith index. So it becomes the ith index will be having 32. Again, move your temp to next node, I to the next node. So you move I to next node, I will now reach 5. It will go out of array, it reach 5. It will reach 5. And moving temp to the next position, what is next? Null. So take and store null in the temp pointer, which means that temp, that the linked list, we have reached the end of the linked list, and temp is now referring to nothing. Null, it is referring to null. Let me take it off. Okay, when temp is reaching null, we can stop the process. And now again let us take temp to the first node itself. Let us again take temp to first node. What we will do, take the address of the first node and assign it back to temp. So again it will come back to pointing the first node. So it is now going to point to first node. Now again take back your I one step previous, because now you are out of array, right? So come back one time. So decrement your I by 1. So when you decrement I by 1, your I1 you will again reach 4th index. That's the last index. Now take ith index element, place it in temp, which means the last data now will be placed here instead of the first node. So instead of 12, replace 32. After replacing 32, now again move your temp to next node, and I you can decrement now, not increment, decrement. So I is decremented to come here to third index. Temp have to be storing the address of next node, which is 345. So it is going to have 345. Okay, and this linking process we are taking it off, and what we will do is this is going to point to the second node. Now take ith index value and place it here in temp of data. So 45 will be taken and it will be placed here instead of 24. So it becomes 45. It becomes 45. And now after replacing it, we have to move temp also to next node, and also I should be decremented. So first of all, we will decrement I. And also we will move temp to the next node, which means taking the address of the next node, which is 100, and let us place it here. So 100. So automatically temp will start referring to the next node. So temp hereafter will not refer to this node, it will refer to third node hereafter. Okay, so the link is now between the node, the pointer temp, and the third node. Now replace this value with the present I value. So taking 13 and again assigning 13 here. No changes will happen, but again we will assign it. After assigning, we have to be decrementing our I variable, and we should be moving our temp pointer to next node. So how to move it? Take the address of the next node, which is 210, and store it here in the temp pointer. So 210 will be here. Now automatically the link between these two things will be gone, and now the new link will be there between temp pointer and the fourth node. Now again, take ith element, place it here in temp of data. So 24 is taken and it will replace 45. So 24 will be the new element. After replacing, move temp to next node, decrement your I. So your I value will be decremented. Now it comes to 0th index. And now move your I to next node. What is the address of the next node? 250. Take 250 and store it here. Automatically temp will point to last node. So temp will be now pointing to the last node. You can check. Yes, having address 250. Now replace this temp of data with ith index value 12. So take 12 and replace ith index element 12 and place it here. After that, decrement your I and also move your temp to next node. So decrementing your I will go out of the array. It will go to -1. Moving your temp to next position. What is your next position? Null. So take null and store it here. Take null and store it here. So null. So automatically the link of this will be stopped. So once temp reaches null, we can stop because it is the end point. So when temp becomes null, we can stop. Now look at the linked list. It is actually completely reversed. 32, which was at the end node, is now here in the first node. 45 is now here second node. 13 third node. 24 fourth node, and 12 is fifth node. So this reversal is actually successful. So what we need to do, so that we will now write a piece of code. Okay. So first thing what I need to do is, let me write void reverse. Okay, let me reverse element, right? This is reverse element. So reverse elements. So reverse element, what I should do is, I will be passing only the address of the first node, and I will be taking it with the help of temporary pointer. So struct node star temporary pointer. It's the only argument that I'm going to take. Inside this function, first of all, I will have to declare array, but before declaring array, I need to find the length of the linked list by once traversing. Okay, by once traversing, I think while you create, at the time of creation, what you do is, whenever you are inserting element, find the length. So after finding the length, so length of the linked list is also one of the important argument. So also send the length also, which is here received with n value. So I can take it as len, length. So now I will take a array of length len, because how many elements are there in the linked list? Same size should be taken here. So after taking ARR of len, now what we need to do is, we need to traverse the entire linked list and we should copy the values here to array. So what I will just simply do is, I will take a variable I. So we will also take a variable I, initialize it to 0, index of the array. Now what I will do next is, I will just write a while loop, and also see address of temp is, now address of the first node is very important. Address of the first node is very important. So what I will do is, I will just take it as first. I will just take it as using first pointer. Here again I will create a temporary pointer, because after traversing to the last node, again I need to come back to the first node and I need to traverse. So address of the first node is very important to come again back to the first node. So let me not change the first pointer. So I will create one more pointer inside the function, which is struct node star. It is going to be temp, and for this pointer we will be giving the address of the first node. So we have two pointer, first and null, which is going to point to the first node. Now we will traverse with the help of temporary node pointer. So I think we already know how to traverse. While temp is not equal to null, you have to move to subsequent nodes by using temp equal to temp of next syntax. So while temp not equal to null, temp is equal to temp of next. temp equal to temp of next. That's it. So while traversing, so before moving from first node to second node, that data have to be copied to ith index of ARR. So ARR of ith index is equal to temp of data. So value is copied successfully. Now after that, what I need to do? I need to first of all increment the value of I, and then I should move temp pointer to the next node. So I plus plus, and then it is temp equal to temp of next. To move temp pointer to the next node, it is temp equal to temp of next. Okay, fine. So once if the loop is over, all the elements could have been copied to the array ARR. Okay, fine. So now next thing that what we should do is, again we should bring back temp to the first node, and also one time we need to decrement I separately because it will be there in 5th index. So we have to take it back again back to 4th index. So the next piece of code that we will start with is, first thing that we will do is, I will be taking temp again to the first node. So temp equal to first. The next thing is, I will decrement your I by one time because it will reach 5th index, which is empty. I will again have to take it back to 4th index. For that, I will decrement I once. Now again what I will do is, again I will write a condition. While temp is not equal to null. What I have to do? Now copy back whatever is an I index. Whatever is an ith index, copy it back to the original linked list. Okay, so now here inside this while loop, first thing that I will do is, in temp of data, copy whatever is there in ARR of I. So ith index element again should be copied back to temp of data. After doing this copying process, what I need to do? I need to be moving. Okay, see here, I think I have done it 2 times. Yeah, temp equal to temp of next, I have done it 2 times. Only 1 time I have to be, right? So after completing this temp of data equal to ARR of I, copying again it back. Now again this temp have to be moved to next node. Temp equal to temp of next, and also I should be decremented now. As we saw in the concept, I should be decremented because we are moving back again, backward direction. So once if this loop is executed completely, then okay, the reversal process could have completed. So what we are doing here, we are taking the data of the linked list and copying it to the array in this first loop. Second loop, from again the array, we are copying it again back to the linked list, but in the reverse order we are copying it now. This will automatically reverse the entire linked list. So this is one way of reversing linked list. This is reversing elements. Okay, fine. So now what we will be doing hereafter is, next we will implement this procedure, and after implementing this procedure, then we will start with reversing a linked list with the help of reversing the links. Okay, reversing the links of the linked list with the help of sliding pointers. We will see what is sliding pointers and how we are going to proceed with that. Before that, we will first of all implement this one. Okay, fine. Thank you, students.